Stretchable optoelectronic materials are essential for applications in wearable electronics, human machine interfaces, and soft robots. However, intrinsically stretchable optoelectronic devices such as light emitting capacitors usually require high driving alternating voltages and excitation frequencies to achieve sufficient luminance in ambient lighting conditions. A novel material developed by researchers from the National University of Singapore (NUS) enables highly visible illumination at much lower operating voltages when used in light emitting capacitor devices, and is also resilient to damage due to its self-healing properties. Imagine a flexible digital screen that heals itself when it cracks, or a light emitting robot that locates survivors in dark, dangerous environments or carries out farming and space exploration tasks. The novel material developed by the NUS researchers could turn these ideas into reality. This innovation, called the Helios, which stands for Healable Low Field Illuminating Optoelectronic Stretchable Device, was reported in the scientific journal Nature Materials. Conventional stretchable optoelectronic materials require high voltage and high frequencies to achieve visible brightness, which limits portability and operating lifetimes. Such materials are also difficult to apply safely and quietly on human-machine interfaces. In order to lower the electronic operating conditions of stretchable optoelectronic materials, the NUS team developed a material which has very high dielectric permittivity and self-healing properties. The material is a transparent elastic rubber sheet made up of a unique blend of fluoroelastomer and surfactant. The high dielectric permittivity enables it to store more electronic charges at lower voltages, enabling a higher brightness when used in a light emitting capacitor device. Unlike existing stretchable light emitting capacitors, Helios enabled devices can turn on at voltages that are 4 times lower and achieve illumination that is more than 20 times brighter. Due to the low power consumption, Helios can achieve a longer operating lifetime, be utilized safely in human-machine interfaces, and be powered wirelessly to improve portability. Helios is also resistant to tears and punctures. The reversible bonds between the molecules of the material can be broken and reformed, thereby allowing the material to self-heal under ambient environmental conditions. Light is an essential mode of communication between humans and machines. As humans become increasingly dependent on machines and robots, there is huge value in using Helios to create invincible light emitting devices or displays that are not only durable but also energy efficient. This could generate long-term cost savings for manufacturers and consumers, reduce electronic waste and energy consumption, and in turn enable advanced display technologies to become both valid and environmentally friendly. For example, Helios can be used to fabricate long-lasting wireless displays that are damage-proof. It can also function as an illuminating electronic skin for autonomous soft robots to be deployed for smart indoor farming, space missions, or disaster zones. Having a low-power, self-repairing illuminating skin will provide safety lighting for the robot to maneuver in the dark while remaining operational for prolonged periods.